Welcome to the first half of the Day 5 video. The Day 5 video focuses on optimization using linear programming. So I'm going to explain what that means as we go through two different examples. Looking at example number 1, you are given the graph of the constraint inequalities. Use a table to find the maximum and minimum values of the objective function. Okay, so there's a whole lot of vocab going on here that you need to know. First thing that you need to know is that constraints are just inequalities. So what we did before is you were given a system of inequalities. So you were given multiple inequalities and you would graph them and you would find where their shading intersected. So looking at our figure, if we were to graph the original inequalities, there would have been one here, there would have been one here, there would have been one here, and then there would have been one here. And when we did all of their shadings, they would have intersected here. Now, the place where the shadings intersect is called the feasible region. Okay, next thing you need to know is that you have what's called an objective function. So this would be the objective function that we're given. Now, what we want to do is we want to find the maximum and minimum value that that function reaches within the feasible region. So what points do I choose in here to get the biggest value of p and the smallest value of p? Now, we're not just going to test any random point that we want. What we do know is that the maximum or minimum value of the objective function is going to occur at one of the vertices of the feasible region. So think about vertices like vertices of a triangle, the points of a triangle. So here we have 4 vertices. The max and min are going to happen at one of those 4 points. Now, you don't need to know why, that's outside the scope of this course, but you do need to know that those are the points that you're going to test. Now, how do we know which point gives a maximum and which point gives a minimum? Well, we're going to have to plug them in. So we're going to make a table. Your table is going to have all of the points and then their value of p. So by all of the points, I mean our vertices. So in this case, we have the vertex 0, 0, we have the point 0, 6, we have the point 2, 7, and we have the point 5, 0. Okay, so our objective function says subtract x and y. So here we get 0 minus 0, which is going to give us 0. We get 0 minus 6, which gives us negative 6. We get 2 minus 7, which gives us negative 5. And 5 minus 0, which gives us 5. Okay, so looking back at the question, we are looking for the minimum and the maximum. So in this case, negative 6 is the smallest value. 5 is the biggest value. So we still have to answer the question. When I say maximum and minimum values, I want to know the value of p. So I'm going to say the maximum is 5 at the point 5, 0. The minimum is negative 6 at the point 0, 6. So you always have to tell me the max and min, which is the p value, and then where that occurs, which is going to be the point. So that's the most basic kind of problem. We're going to get a little bit trickier with a problem like this. In a problem like this, we have to graph the inequalities first. So we need to sketch the inequalities, label the vertices, then we need to find the maximum and minimum of the objective function. So again, looking before, this is our objective function, our p-value. This is what we want to find the maximum and minimum of. These are our constraints. So this is what we need to graph. So you're going to need a straight edge. X is greater than or equal to 0 is going to be a line here. This is going to be a solid line. Greater than is going to be this way. So that's this one. If I want y is greater than or equal to 0, that's going to be a horizontal line. Greater than is going to be up. So that's our second constraint. And then this is going to be our third constraint. Now, if we remember how to graph this from before, this is standard form, so we're going to want to make a table. If I put a 0 in for x, I get y to be 6. If I put a 0 in for y, I get 2x equals 6, so x is 3. So these are the 2 points that I'm going to graph. So 0, 6, so 1, 2, 3, 4, 5, 6. And then 3, 0 is going to be here. You want to make sure that you're using a straight edge. Okay, so we need to figure out the shading still. If I plug in the origin 0, 0, I get 0 is less than or equal to 6, which is true. So I would shade towards the origin. Okay, so our feasible region happens where all 3 of those inequalities intersect, where all the shading happens at the same place. So that would be this triangle here. Now, in most of the examples that we do, your feasible region is going to be a closed region. So it's going to have a starting and an ending, but that's not always the case. So just make sure that we're paying attention. Most of the time, you should have a closed region. Okay, so that was the first part, sketch the graph. Now we need to label the vertices. So this vertex is 3, 0. This one is 0, 6. And that one is 0, 0. Now, you're not always going to have 3 vertices. If we look at the first example, in this case, we had 4 different inequalities and we had 4 vertices. So you could have more than 3 constraints, more than 3 inequalities. You could have more than 3 vertices, or you could have 3 of them. Okay, now we need to find the maximum and minimum. Like we talked about above, the maximum and minimum are always going to occur at one of the vertices. The way to figure that out is to test them. So I have x, y, and I have my p is 3x minus y. So I have the point 0, 0, I have the point 0, 6, and I have the point 3, 0. Now, if I plug all of those in, I get 3 times 0 minus 0, which will give me 0. Here I get 3 times 0 minus 6, which will give me negative 6. Here I have 3 times 3 minus 0, which gives me 9. So negative 6 is the minimum, 9 is the maximum. We still need to answer the question. Now remember that when I say find the maximum or minimum, I mean the p-value. So we're going to say the maximum is 9 at the point 3, 0. The minimum is negative 6 at the point 0, 6. Okay, so a few reminders. It is really important that you use a straight edge. You have to use a straight edge to make sure that you get the correct vertices. Because if you draw the inequalities wrong, you're going to end up with the incorrect vertices and then the incorrect max and min. So make sure that you're using a straight edge. Make sure that you're checking to find the feasible region. And then remember that your max and min is always going to occur at one of the vertices. When you come to class tomorrow, we're going to continue with this idea, but we're going to apply it to some word problems.